Hello, my lovely humans. So what we got going on here is 2023 question 2B, or not 2B, oblique collision question. I'm going to type most of this except for a few bits of triangles at the start, just so you get a feel for how I think you should lay it out on the page. So we'll have a look. So two smooth spheres, so smooth means there's no friction in the collision, which is good because we don't know how to do that, have equal radius and are of mass m and 2m, respectively. P and Q collide obliquely. So that means they don't collide directly, they collide, and it's going to usually be along one of the axes. I hope to all that is unholy that we don't see a collision along a diagonal, because that would cause an enormous amount of algebra or trigonometry. So let's pretend that's not going to happen. The line joining their centers at the point of impact lies along the I-axis. So that sentence is that they collide in the I direction, horizontally only, which means our vertical speeds are maintained before and after the collision. So before the collision, sphere P moves with velocity 4 and angle alpha with the I-axis, where sine alpha equals 4/5. So I'm like as soon as I see sine alpha equals 4/5, you have to draw a quick triangle for yourself. It just needs to be a right angle triangle. Sine alpha is 4/5, means it's opposite over hypotenuse. And that means, so we know sine alpha is 4/5. And it's a 3, 4, 5 triangle. So Pythagoras is going to tell us that that's 3. So that means cos alpha is 3/5. And tan alpha equals 4/3. Now, we don't know what of those we're going to need, but you just write them down so you can read them off and not have to think about them, because thinking is your enemy in this exam. You only have a certain amount of thinking power in your brain, so let's try and do things to help us think as little as possible. So, I suppose, like the projectiles question where we have split everything into x's and y's, I'm going to do the same thing here via a table. So we're going to say the I direction and we're going to say the j direction. Now you can use x and y if you prefer. I'm just going to stick with what the Mr. SEC, or the gender neutral SEC human, has decided. So in the I direction, we have P and Q, and we have before and after as well. So this is going to get quite confusing. So actually, not I's and J's. We're going to do befores and afters. Sorry. Before and after. Because that's the in projectiles, the division of stuff was the x's and y's, because we only had one thing thrown. Here we got two sets of everything, and some of them are before, some of them after, and the before things have values and the after things have related values. So let's see what we need to see. And actually I'm going to do a third column here. Just give me a second. I realize there's and I'm going to just say constants, because constants will be quite useful. So the constants we got going on here are the mass of P, which is m, the mass of Q, which is 2m, and E, which is E, because we don't know what E is. So they're the constants we have to work with, which are, well, constant. They are the same before and after any collision. So what we know now is and then here's how u x of p. So the left-right speed of p before the collision is 4 by cos alpha. Now, how the hell did I get the 4 cos alpha? So if you look at it here, we have, this is our speed 4. There's our angle alpha. And we know that has to be the hypotenuse times cos alpha. And this is the hypotenuse times sine alpha. If you prefer to do this in i's and j's, that's fine too. There's just, this is a way that I feel makes sense. So uy makes sense for me anyway, which is the most important thing, is 4 sine alpha. Okay. Then let's have a look at, say, at q. So u x of q. So what's q has 0 left-right speed before the collision. Ground. Okay, and u of y of q equals 3.2. So that's what's going on before the collision. After the collision now, we don't know what the Vx of p is. Vx of p. We don't know what that is, the left-right speed of p, so I'm just going to call it lowercase p. We do know, however, that the y speed of p after the collision, so the Vy of p hasn't changed because the collision is only in the I direction, in the left-right, so this has to be 4 sine alpha. So that this property is how we are going to link these things together. Now we don't know what the Vx of q is, the speed of q after the collision, so I'm just going to call that q, hopefully for obvious reasons. And then we do know that y of q equals 3.2. So the reason I do this way is so that we have something to look at. I don't know how much of these we need to solve the problem, but I do know everything is here and I don't need to think about it ever again, or to think about what they are. We just now know we have everything we need to solve the problem. So again, we want E, so it doesn't hurt to say we want E. Can't hurt to write that down just to remind yourself of what it is. So with collisions, we have on page 51, we have our PCM and we have our NEL. So our PCM is M1 U1 M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. And we just need to decide what's 1 and what's 2. So it's P's and Q's or whatever. You decide. I would usually use the thing that I've written first as 1 and the thing I've right second as 2. So in this case, P will be 1 and Q will be 2. And then our Newton's experimental law is V1 minus V2 equals minus E U1 minus U2. And again, whatever we decide is 1 for PCM has to be 1 for the NEL. So the principle of conservation of momentum. What that tells us is And now the key here is in an oblique collision, the PCM only happens in the direction of the collision itself. So you'll notice that everything in the Y is the same before and after, so that is not part of our PCM. Those are the things we don't include because they're the same, they don't change. They are conserved by default. We want to find the things that aren't, not by default, just the numbers are the same, so then it is, in theory, obviously conserved. But we want to find the things that are, we know have to be conserved, but we don't know what the values are, and that's the stuff in the X direction as I've put it. So M1 is, so the PCM in our X direction is M by 4 cos alpha plus M4 cos alpha plus 2M by 0, and I'll just write in just the X direction, and that equals M by P, because P is our X velocity, plus 2M by Q. So just working that out for a second gives us, we can divide M out by everything, gives us 4 cos alpha equals P plus 2Q. We know what cos alpha is. Totally forgot, we've written it down there as 3/5. So this means that 4 by 3/5 is 12/5 equals P plus 2Q. Okay, that's pretty good. This means I think we're going to get a simultaneous equation, and it's all just going to be nice, we hope. So that's our, I'll just write in brackets here, cos alpha equals 3/5. Now, a lot of people reach for the calculator to find out what alpha is, but actually that takes more time and is less accurate. So we don't care what alpha is. So if we know sine alpha, we can know cos alpha with bypassing what the alpha is altogether. And now we look at the Newton's experimental law, remembering that P is our 1, so it's V1 minus V2, so that's P minus Q equals minus E by 4 cos alpha. I know the value, I'm just writing it down to make sure I get it right, minus 0. Okay. So this means P minus Q equals minus E by, and cos is 12/5. Okay, so now we have and we want in terms of E the velocity of each thing. So we want to find out what P and Q are, and they will have E in there. So what I'm going to do is write P equals Q minus 12E over 5 from that NEL equation, which means that then 12 over 5 equals Q minus 12E over 5 plus 2Q. And then that turns into 12 over 5 by 1 plus E equals 3Q. And now just pause and go back and make sure you're happy that this is correct, because it is. So that would mean Q equals 4 over 5 by 1 plus E. And if so, that's our Q, and then that means that P equals 4 over 5 by 1 plus E minus 12E over 5, which means that P equals 4 over 5 plus 4 over 5, 4E over 5, minus 12E over 5, which means that P equals, we can take 4/5 out, and that will leave us 1 minus 2E. Okay, so that's found our P and Q. So the final thing we then want to write is VP is what is it in the x direction and what is it in the y direction. So in the x direction it is P, so that's 4/5 1 minus 2E I. Then what is it in the j direction? Remembering that hasn't changed, so that's 4 sine alpha, which is 4 sine alpha, which is 16 over 5. I'll let you guys figure that one out yourself. It is correct. And then VQ is 4/5 1 plus E I, because that's the I direction. And then what was the speed? It was 3.2. So it was plus 3.2 J. And that's your answer there. And it's key. So what's really important is because it asks for the velocity, you have to write it in terms of how much in the I direction and how much in the J direction. If it just asks for the speed or the speed in the J direction or whatever, you could write one number. But because it asks for the velocity, we have to write it out in one go like that. And you don't need to turn those fractions into decimals. You can if you want, if you think it looks better. It's totally up to you. I would leave it like that because I don't think you'll get any extra marks for it. But if it makes you happy, 0.8, 0.8, and 3.2. 3.2. It's 3.2. Yeah, it's a strange one. So if you want it makes you happy, that's the answer there, and that's what the marking scheme will give us. So the things to remember, and please go back and look at this, the things to remember are turn everything from triangles into horizontals and verticals, use your angles or use your sine to get your cos, and remember that the momentum and the Newton's experimental law only happen in the direction of the collision, which in this case was the I direction. So we'll have a quick look at the marking scheme and where things come from. So you get 5 marks for writing out what P and Q have to be, and so 5 marks for writing out what P has to be, and 5 marks for what Q has to be. So that's, sorry, space pen. So 5 marks for P, 5 marks for Q. 5 marks for writing out the Newton's experimental law. 5 marks for writing out the, so no, 5 marks for the principle of conservation of momentum, and then 5 marks for Newton's experimental law. Not actually even working them out, just writing them out. And then you get this, and you got 5 marks for getting that right, and 5 marks for getting that right. So this is what, a 5, 10, 15, 20, 30 marks for this. It seems fairly standard. If a collision like this comes up, it is something you will have seen already, and you can just you can just plow through it quite quickly. Make things easier on yourself. Draw your triangle with the alpha. Write out everything in the table just so you know exactly what you have to work with and exactly what we don't know. And then use your stuff to figure out what's going on. There are other questions from before the new course around things turning through angles and things, and there's a lattice molecule thing which I might get to later. But for the moment, that's how you do oblique collisions. Make your angles, write down everything we know and all the unknowns we have as well, and then just go through the two formulae and then turns into simultaneous equation and you get an answer. So I hope that helps. I will see you again, I imagine. Good luck.